Okay guys, we're getting closer and closer to the end of the year, so it's about time as we start reviewing. So if we go back to the beginning of the year and we look at number systems and some of the stuff we did at the beginning of the year, either of my class or Brimhall's class, today we want to look at comparing rational versus irrational numbers. So hopefully with all this review, if you stayed caught up, these things should be pretty easy. So rational numbers, if you can remember, rational numbers are numbers that end. They stop. So any whole number like 7, 100, 134, any whole number like that that just stops, comes to complete ending, that is a rational number, even if it's negative. So you could have like negative 13, negative 25, negative 562, okay? Those are all rational. Any number that comes to a stop, any whole number. Okay, that includes decimals. So if we just got like 0.4, it stops, it terminates, it doesn't keep going. That's rational. 0.125, okay? It stops, there's an ending to it. It's rational. If it's negative 0.37, okay, that's also rational. It comes to a stop, it ends, it terminates. Alright? Fractions. Any number that you write as a fraction, like 1/2, that's rational. 7/8, that's rational. Mixed numbers, 4 2/5, that's rational. Even if we want to make it negative, let's say negative 3/4, that is rational. Okay? So any number that comes to a stop or that we can write as a fraction is always rational. Alright? What about if it repeats then? So we got 0.35 and we put this bar over it. That bar means it repeats, it keeps going. Another way of saying this is 0.35, 35, 35, dot, 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 dot. Right? These mean the same thing. These dot, 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 dot means keeps going. And the repeating bar means it keeps going. But it repeats. There is a pattern. So therefore these are rational. Okay? So if it stops or if it repeats, it's rational. 0.127, 127, dot, 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 dot. That is rational. Okay? There's a pattern. 127, 127, so on. If it goes 0.123, with a bar over it, once again, that's rational. If I put a whole number in the front, like a 4, it's still rational. It repeats. If I go back in and put a negative sign there, it's still got a pattern. It repeats. It's still rational. Okay? So all these concepts, whole numbers, positive, negative, decimals that terminate positive, negative, fractions, repeating decimals, they're all rational. Okay? So the big thing that you need to remember is what is an irrational number then. Okay? Which ones were irrational? Irrational numbers are the numbers that go on forever, that don't stop and don't repeat. The famous irrational number is always pi. If you type pi in your calculator and hit equals, it says 3.14159, I think 6, I don't know. And then it just keeps going. Your screen runs out of space, but pi is a famous number that goes on forever. If you look at your numbers, it goes 3.14159, like 26. There is nothing repeating. There is no repeating pattern. The dots mean it goes on forever, but it doesn't repeat. Therefore, we call this irrational. Okay? You can create any irrational number. Just put a decimal and then start putting a bunch of weird numbers. 1, 7, 3, 4, 6, 8, dot, 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 dot. There's no repeating pattern. I put the dots to say it keeps going on forever, so therefore it's irrational. If I go 0.1, 2, 3, 4, 5, 6, 7, dot, 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 Sometimes kids get tricked on this one because they're like, oh, there's a pattern. We're counting by ones. No, that's not what we mean by patterns. It's got to be a repeating pattern. So there's nothing repeating, and there are the dots again. It goes on forever, therefore it's irrational. Okay? So if I gave you this one, 0.127816 dot dot dot, and I gave you 0.192192 dot dot dot, which one is rational? Which one is irrational? The top one, there is no repeating pattern. Hopefully you said irrational. The bottom one, you see 192, 192. It repeats. Therefore, it is rational. Okay? But once again, if you see any number that stops, it's rational. Any fraction, it's rational. Any repeating decimal is also rational. The only ones we're looking at irrational are ones that go on forever with no pattern. Okay? There's one other type of famous irrational numbers besides just decimals that go on forever. We need to be careful and look at some square root numbers. We've done square roots a ton in our 2 classes. Please tell me you remember how to find square roots. Square roots is the number that's times itself that gives you this. So if we're asking for the square root of 25, what times itself gives you 25? If you don't know, put it in your calculator. Square root of 25 is 5. Whoa, 5's a whole number. It stops. Therefore, it must be rational. But let's say we take the square root of like 27. What number times itself gives you 27? There isn't one. So if you put this in your calculator, you roughly get like 5.19 dot 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 so on, right? It's gonna be something. I'm guessing it's a 9. I don't know. I have a calculator in front of me. 5.1 something dot 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 dot. It doesn't repeat, and it goes on forever. Therefore, it is irrational. Okay. So the square roots are ones that you have to put in your calculator to find out. So pick your calculator up and don't be lazy, use it. So if I ask you for the square root of 81, is that rational or irrational? Well, those that know their times tables know it's 9. 9 times 9. If you don't, use your calculator. Square root of 81 is 9. And 9 is a whole number, therefore it must be rational. Square root of 40. Is that rational or irrational? Those that know their times tables know there's nothing that times together gives them 40. Please don't tell me you told me it was 20, because 20 times 20 is not 40. But if I put it in my calculator and I go square root of 40, I roughly get about 6 point something something something, and it keeps going and keeps going and keeps going. It does not stop or does not repeat. Therefore, this is irrational. Okay? So today, once you are done with this video, you're going to watch an Ed Puzzle video. And then the Ed Puzzle video is going to explain some more on rational and irrational numbers if you don't like my video. And then when you're done with that video, you'll go pick up your assignment from Mr. Holtz in the back of the room and get it completed. Your assignment today will give you questions simply like this. They'll give you a number like 14. And you tell me, is it rational or irrational? Well, it's a whole number, so you simply just say rational. Then they'll give you one like this, and they'll say 2/5. Is that rational or irrational? Well, it's a fraction, so therefore it must be rational. Then they'll give you numbers like this, 0. Oh, well, it's a number that stops, therefore it must be rational. Then they'll give you ones like this, 0.125, 125, dot, 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 dot. And they're like, what is this? Oh, it's got a pattern, it repeats. So therefore it must be rational. Then they'll give you ones like 0.781462 dot 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 dot. Oh, there is no repeating pattern, and it does go on forever. So this one must be irrational. And you'll also have some square roots in there, so once again you will need to use your calculator. So if it asks for the square root of 36, well, that is 6. 6 times 6, so therefore it's rational. And they'll give you ones like square root of 10. Oh, you put that in your calculator and you see it's like 3.1 something 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 something. It goes on forever and does not repeat. Therefore it must be irrational. Okay, this is what we're going to be reviewing today. These are easy points on the end of level test. So enjoy your videos. When you're done, come see me for your assignment.